All right. So I had to pause the video because it was getting too long and I could not figure out um, my error because it was saying value error array must not contain INFS or NANS. I would love to explain how I fixed that, but I honestly just retyped it over and over again, and I added like a little spacing here, and it worked. So I don't know the logic behind that one, other than sometimes turning it off and turning it on again works. I don't know. But we're gonna finish up this code. We're gonna graph this, and we're still having an error with our calculations. So we fixed the first problem, and now we're fixing the next problem. This also, okay. When all else fails, run the whole code, I guess. All right, so I guess our error there was that we weren't running the whole code, and it was missing. It was probably not taking our conditions that we set. But yeah, that looks good. So basically, this is showing the calculations of our temperatures at each. It's calculating at each increment over time of our initial temperatures. And that looks pretty good. And then another thing we can do is check our R value for stability. 0.25. So 0.25, we can change our R value. So yeah, sorry. One way we can check the stability of our results at specific values, and one way we can check our result values at specific points in time is by changing our number, our delta x, I believe it is. So 8, run all, and that should change our R value. No? Huh. It's pretty sure, maybe it's not increasing the, oh, okay, I see what I'm doing now. I know we're super close to being done. It's not these conditions I need to change, it's these. So I can change it to something smaller, so I can do 0.5. Run it all again. And that will change our R value, so we can increase or decrease our R value just by changing our our delta x, which is our change in spatial divisions, or I think we can also do it by increasing our number of nodes. No, I don't know if that does anything. But yeah. And it's looking pretty stable. We can check by our increments in time if we put 155 here. And let's run it all and see if it's stable. And it is stable. Perfect. All right, so what we did, a little overall review, is that we derived a forward differencing scheme for calculating the time varying temperature profile, in which we did in part 3. With our expression here. And then we plotted that and we checked the stability. We found that it was stable at 0.5 for our change in for our delta t. But if we changed it by like 1 point, it was unstable. And so we added our Crank-Nicolson's method to our R expression. And then what we did after that was we implemented the Crank-Nicolson's method and plotted the temperature profile as a function of time with our matrix of our left-hand side expression and the vectors of our right-hand side. And we solved a series of, so we simultaneously solved a series of linear functions in which we calculated our temperatures at each increment in time. And that is plotted here. And that is the solution for exam 3. Awesome.